Hello everyone, I hope everyone is fine. I am Radha Kumari Pani, Assistant Professor at Vedang Institute of Technology. So, we have discussed a lot topic about the phase transformation process, okay, which is the part of metallurgical engineering. So, in last class we have discussed about the kinetics and the Arrhenius equation, and one problem we have done basing upon this Arrhenius equation. So, what Arrhenius equation? The original, the general equation, that is K is equal to AE to the power minus EA by RT, where K is your equilibrium constant and A is pre-exponential factor, okay, and EA is activation energy, R is gas constant, and T is absolute temperature. And the integral form also we have derived from the general equation, that is log K1 by K2, that is equal to EA by 2.303 RT, 1 minus T1 by 1 minus T2. So, in today we will going to discuss about the another topic, that is diffusion. Okay. The term diffusion generally it has been come from chemistry. Okay. What is diffusion means? Diffusion in general we can say, in chemical words we can say, diffusion means it is the flow of ions or molecules from higher concentration to a lower concentration area against the concentration gradient. Okay. In chemistry we can say like this, but in generally we can say diffusion means it is the one type of randomness we can say, or the spreading out of molecules, okay, generally which can be seen in gaseous or liquid phase. Generally it is the property of flow of a liquid. Okay. So, first see, diffusion is the randomness of molecules, okay, in the solid, liquid or gaseous. For example, we can say the ink in water, the smoke in air, means randomness of molecules can move here and there like anything, and the driving force is thermal energy and the concentration gradient. Okay. Thermal, because of thermal energy, if you are treating some giving some thermal energy to a crystal or materials, anything we can say. So, due to the thermal energy, thermal vibration will happen. So, due to the thermal vibration, the activation energy, okay, the activation energy of that molecules will cross the barrier, so that it can jump from here to there, it can move to adjacent side, it can move to interstitial side, or the randomness will be more. So, the driving force for the diffusion we can say the thermal energy and the concentration gradient. If the concentration is more in this side, is less in this side, so that the molecules will always the molecule will try to have the equilibrium. Okay. So, the molecule will move from higher concentration to lower concentration. That will be another reason for diffusion. So, here which can be the role of diffusion in the materials, different properties can be there. First is oxidation. Oxidation means adding of oxygen or removing of hydrogen, adding of oxygen to the materials. Okay. So, it can be one type of diffusion. Okay. If you are adding some foreign materials, let us say oxygen to the material, so the randomness will be more, like the compact structure will be hampered, okay, like this. So, another one is sintering. Sintering generally it is the heat treatment process, generally it is a heat treatment process to the powder compact material, so that the diffusion can be occur. So, doping. What is doping? Doping means, what is doping? Doping means the adding of foreign metals, adding or introduction of foreign metals to the materials. Doping words you must have heard from semiconductor topic, okay, like what is doping, intrinsic in extrinsic semiconductor. So, doping is nothing but it is the adding of foreign metals to the material, so that the diffusion occur. Now, creping and aging, this is the deformation, okay, this is we can say the metals deformation, so that the diffusion will be occurred. Then carburizing means the adding of carbon. What is carburizing? Carburizing means the adding of carbon in iron or nickel metals, okay, so that diffusion will be occurred. So, this is the role of diffusion in different cases. Now, diffusion under the thermodynamic driving force. Okay, how the diffusion will be responsible for in chemical potential in like Gibbs free energy in thermodynamics term. Okay, so see here the graph is shown here. In the y-axis free energy, that is Z is given, and in the x-axis composition of B. Okay, let A and B are the two different pure materials. Okay, here A, here B, and from that graph here you can see this is the mu A, means chemical potential of A, pure A, and this is the Gibbs free energy of pure A, and this is the chemical potential of pure B, and this is the Gibbs free energy of pure B. So that from that graph we can see if you are increasing, okay, see this is at 0, means at xb is equal to 0, means at pure A only, in the materials only A is present, so that the chemical potential will be mu A, and where the xb is equal to 1 means the pure B metals is present, that in that case chemical potential will be mu B. So from the graph we can see the Gibbs free energy if we are decreasing, okay, if we are decreasing from 1 to composition from 1 to 0 side, so that the Gibbs free energy of B is going to decrease in the such a way that so that it will attain equilibrium, that is Z star. At this point it will attain the equilibrium of pure A and B materials. Like this, Ga also, the Gibbs free energy of A will goes on decreasing by increasing the what? By increasing Xa. Okay. So it will behave same like that. If we are decreasing the B concentration from 1 to 0, Gibbs free energy of B also will go decreasing, and Ga also will goes on decreasing. So like that, if you have formula minus RT ln A, here A is activity concentration we can say, that is Za minus mu A, and like this minus RT ln AB, that is Gb minus mu B. So like this, if the Ga goes on decreasing, then activity also will goes on decreasing. Okay, so from that graph it is clear mu A and activity concentration of A and mu B and activity concentration of B follows the same trend of increasing and decreasing with Xb, that is mole fraction of B. Okay, or we can say the composition of B. If you are decreasing the Xb from 1 to 0 side, then the Gibbs free energy of B metals also will goes on decreasing. At some point Ga and Gb will attain equilibrium, that is Z star. At this some composition of Xa and Xb, some composition will be there. In that composition it will attain the equilibrium state. So here, okay, that in the case of pure metal, if you are considering two AB alloys, okay, different composition, let one is P and Q. In P, let the composition of A will be more, and in the Q composition of B will be more. So in that case, if you are looking after this graph, what will happen? This is the pure chemical potential of P, and this is the chemical potential of Q, and at A end, if the A concentration of A will be more, and this is the chemical potential of P and Q, in that case the concentration of B will be more. So however, so this can be better understood by seeing this alloys. Okay, this is the alloy. If we are combining those two PQ alloy, in P case a composition of A will be more and Q composition of B will be more. So what will happen if these alloys are kept separately? Okay, if our alloy kept separately, those have different free energy, that is Gp and Gq. If we are bonding these two blocks, okay, annealing will happen, but the amount of material P and Q are taken in such a way that they will attain the equilibrium at mole fraction R. Okay, this is the Gr is the Gibbs free energy at equilibrium concentration, that is R, so that the system will try to move to its new equilibrium free energy. Okay, so it can only move the equilibrium composition by solid state diffusion, because these two are solid material. By the solid state diffusion it will attain the equilibrium at equilibrium composition R and the Gibbs free energy, that is Gr. So this is the different time interval how the composition graph will be shown here. Okay, this is the T0 and T1, T2, T3, T4, T infinity, different time interval how the P and Q materials will behave if you are increasing the composition of Xb. See, this is the graph. It is called sigmoid graph or S shape, or we can say sigmoid. Okay, so this is the happen in the, you can we can say in the thermodynamic parameter how we can define the diffusion. If the diffusion is happening between two pure metals A and B, if and the diffusion is happening two alloys, that is P and Q. In P A is more and Q B concentration is more, and the Gibbs free, how the Gibbs free energy will behave like this, see, and the different time interval also P and Q, how it will respond. So now diffusion mechanism. See, diffusion mechanism means what is the mechanism? Mechanism means it is the pathway. Okay, just like kinetics, it is the pathway how the diffusion is occurred in different types, in different process. So there are like many types are there, mechanism we can say, like here vacancy mechanism one is there, interstitial mechanism one is there, and as dislocation pipe like pipe mechanism, and another one is interdiffusion mechanism, different types of mechanism, grain boundary surface. Okay, so we'll discuss one by one. So now what is vacancy mechanism? So this vacancy mechanism will only occur in the materials if empty space should be there, vacancy we can say. The like diffusion of atoms involve movement of steps from one lattice to another. Okay, this will occur only if the adjacent side should be empty and the breaking of bonds should be occurred. The breaking of bonds with the neighboring atoms, this is let the atom, it will break the bond from the neighboring atoms and it will come to the vacancy site or lattice site we can say. So this mechanism involved with the movement of atoms. Okay, movement of atoms to the empty or adjacent vacancy site from the regular lattice sites. So this empty site and the vacancy exchange their direction. So the vacancy, the flux will be in opposite direction. Here another example is there, this atom, okay, will come to this vacancy site. Here vacancy mechanism will be occurred. Here this also. After this coming to the vacancy site, another vacancy site will be created. So this is the one type of diffusion mechanism, that is vacancy mechanism. Another one is interstitial mechanism. In interstitial mechanism, what will happen? So in materials, if the impurity is occurred, okay, let carbon in steel. So there will be lot of vacancy site or vacant, okay, so that the atom can move to interstitial site from that regular lattice point. So in that case, diffusion will be occurred and the mechanism is known as interstitial mechanism. Okay, see here a graph is there, let from this interstitial side to this side diffusion will be happen, and let this interstitial atom will come to this side, the diffusion will be occurred. So this mechanism is morely prevalent in impurities such as hydrogen, carbon, nitrogen, oxygen. In that materials, this interstitial diffusion will be happen. So another one is atom interchange mechanism, means in the materials atom are going to interchange their position. One is direct exchange from this atom to this atom, okay, one is ring exchange, means four atom will exchange their position from this to this, this to this, this to this, and from this to this, okay, so that the vacancy will be created in the materials, the diffusion will be happen, and generally the rate of diffusion will be more in rapidly cooling state. In if you are fast cooling the material, okay, if you are cooling in the fasting process, so that the large number of vacancy will be created in the materials, and so that the atom interchange mechanism will be happen. And the fourth type is pipe diffusion. Here in the last slide we have seen vacancy and the interstitial, and one is interchange exchange, that is happened only in lattice side, but here the diffusion will be happened in pipe like shape, okay, some edge dislocation will be happened. From here you can see clearly this is the pipe diffusion, okay, from it can be seen like that, so movement of atoms through a pipe. So here The dislocation here, this is the region that is a lower activation energy, so that the diffusion will be more as compared to atom interchange or vacancy or interstitial mechanism. Pipe diffusion will be more, because here the activation energy, activation barrier will be less, so the rate of diffusion will be more. Now, grain boundary diffusion. Okay, this is another one is grain boundary diffusion. What is grain boundary? Grain boundary means this is nothing, this is the interfaces between the two materials or two crystals. Okay, so these are the relatively more open structure as compared to atomic structure. Okay, in that case diffusion will be happen due to the misorientation, the diffusion will be happen, and this is also the rate of diffusion will be more as compared to atom interchange or vacancy mechanism. Now is surface diffusion. What is surface diffusion? Surface diffusion means when the diffusion occurred over the surface. Okay, over the surface the diffusion is occurred, that diffusion is known as surface diffusion, and here the rate of diffusion of the surface diffusion will be more as compared to others. You can see from the graph diffusion coefficient, that is D, with 1 by T the surface diffusion will be more, then grain boundary, then lattice. Okay, in lattice will come 3 diffusion, that is vacancy, and another one is interstitial, and the third one is atom interchange diffusion. Okay, because the dislocation throughout the pipe through the edge will be more, because the activation barrier is less, so the diffusion coefficient will be more in the case of surface mechanism. So now what is diffusion couple? Okay, diffusion couple means if the two materials, let A and B, two block with the different composition, if you are going to bond, okay, if you are going to breaking a bonds or annealing between them, and the JA is known as diffusion couple of A and JB is known as diffusion couple of B. Annealing is nothing but if the two different materials of two different composition, if you are going to bond, okay, with each other at the interfaces, they will form the another compound that is known as anneal or annealing. The process is known as annealing. So this is the diffusion couple, and symbol is J. What is interdiffusion? Interdiffusion means the element, the two different elements are combining, are coupled or diffuse between themselves. Let some example, zinc and copper. The two different materials of different composition, they will interdiffuse between themselves, so that the diffusion is known as interdiffusion, and the coefficient is known as chemical diffusion coefficient. Okay, and the diffusion of these elements are known as intrinsic diffusion of element. Between the interdiffusion means between the two metals. See, like interdiffusion, there is another diffusion, that is self-diffusion. What is self-diffusion? Self-diffusion means the diffusion between same elements of one atoms. Okay, of one materials we can say the diffusion occur between in between the same crystals. But here in this type of diffusion no driving force is required, because see, self-diffusion means it is occurred by themselves only, because of the jumping of atoms from one position to another position, and this is happening in high elevated temperature. If the pure metals, okay, the pure metals is kept at high elevated temperature, then the vacancy and the vibration will be of atoms will be occurred, so that the atoms will go to from lattice, regular lattice site to another lattice vacancy site or another position, so that the diffusion is occur. And the example is let indium and tin. This type of low melting point, generally this will be occur only in low melting point. So at low melting point means the activation energy barrier will be less, so that the by heat treatment, small heat treatment, the metals can move here to there, so that diffusion will be occurred. Now the last one diffusion, that is tracer diffusion. What is tracer diffusion? Tracer diffusion is only occurred in the radioisotopes. Okay. Tracer means we can trace the diffusion, okay, like from where to where the atoms will be diffused, and this will be occurred by only 1 or 2 neutron mass difference. Okay, so diffusion we can say the randomness of molecules, or we can say the atomic mass transport of atoms. Okay, So in tracer diffusion, only the 1 or 2 neutron mass difference will be happen, and the diffusion rate of these tracer atoms are called tracer diffusion coefficient or D star. Here the relation is there, D star is equal to F into ds, where D star is the diffusion coefficient of tracer, okay, and ds is the self diffusion, and this will be equal by some factor F, and F is known as the correlation factor. Here the element, if we are diffuse the element of B in pure metal A, then this will be the happen at time 0 and at time t1 this will be diffused, okay, if the B metals will be diffused to A pure metal. So this is known as tracer diffusion, and the relation between the tracer diffusion coefficient and the self diffusion coefficient is this, D star is equal to F into ds. So this is the end of this topic, what is diffusion and what is the diffusion mechanism. So we have learned today what is diffusion means, it is the randomness, or it is like it is the property of flow of liquid, so that the any atoms or any molecules move from one side to another side. And also we have learned about the different types of mechanism, what is the different mechanism are there. Lattice diffusion mechanism is there, like vacancy, atom interchange and interstitial, and another one is throughout the surface diffusion and grain boundary diffusion. What is self diffusion? Self diffusion means the diffusion occurring between the atoms. Interdiffusion means two different materials of two different composition are interdiffused to form the at interface, they form the another materials and their diffusion couple is happening, annealing is happening. So the one term is raised, that is diffusion couple J. And we have seen the what is tracer diffusion and what is the relation between the tracer diffusion coefficient with the self diffusion coefficient, that is D star is equal to F into ds, where F is the correlation factor. So in next class we will discuss about the, that is one another important topic, that is Kirkendall effect, what is Kirkendall effect and what is Fick's law. So till then, take care, bye bye, thank you so much.